Let us start foundation chemistry. In foundation chemistry, we'll see valence shell electron pair repulsion theory. In the foundation chemistry, we are taking covalent molecules. We'll take for covalent molecules how to say the shape, that we'll see. For covalent molecules, how to say the shape, we'll see. For which theory we are taking, in the sense valency shell electron pair repulsion theory we are taking. Valence shell electron pair repulsion theory. This theory we are taking. Okay. Now, for this, we want to know it. Generally, atoms is going for bonding, in the sense how many bonds it will make. That we want to know it. Suppose if we take hydrogen, its atomic number is 1. Therefore, it is having 1 electron. So it can make 1 bond. It can make 1 bond. Okay. Sir, oxygen, if we take, its atomic number is 8. Its electronic configuration is 2,6. The valence shell, this is outermost shell, it is having 6 electrons. It is in need of 2 electrons to get octet. Therefore, it can make normally 2 bonds. This 2 bonds, how it will make, in the sense, one possibility, 2 single bonds it can make. It can make 2 single bonds. Otherwise, it will make double bond. It will make double bond. Double bond in the sense like this. Single bond in the sense like this. Okay, oxygen will make like this. Now, nitrogen, if we take, its atomic number is 7. Therefore, its configuration is 2,5. The valence shell is in need of, the valence shell contains 5 electrons. The outermost shell contains 5 electrons. Therefore, it is in need of 3 electrons to get a octet. So that normally it will form 3 bonds. Normally it will form 3 bonds. 3 bonds in the sense, one possibility is triple bond. One possibility triple bond, that's what we have discussed in N triple bond N2 molecule. Otherwise, 3 single bonds, 1 double bond, 1 single bond. Like this, many possibilities are there for this nitrogen. Okay, sir. Oxygen also double bond, in the sense O double bond O, oxygen molecule O double bond O. Like this we are saying. Sir. In this concept, some of the molecules shape we have discussed in the previous class, one class we have discussed. Continuation of that only we will see. Now we will take the molecule called SnCl2 we will take. SnCl2 I will take. SnCl2 name is what, in the sense stannous chloride. Like this, another possibility also there. What is that? Means SnCl4. What is this name, in the sense stannic chloride? Why the name is getting difference? That we will see. For which we will go for crisscross method. Here 1 we will take, this 2 we will take here, this 1 we will take here. So Sn is getting charge 2 plus, Cl is getting 1 plus, 1 minus. Cl is getting charge 1 minus. Okay. This 1 goes to Cl, therefore Cl is minus 1, 2 goes to Sn, Sn is plus 2. Generally cation first, anion next. Here Sn plus 2 is there. Here Sn charge is plus 2. Tin, Sn is called tin. Tin charge is plus 2. Here also we will do crisscross method. Okay, crisscross method, 4 goes here, 1 goes here. Therefore Sn is getting 4 plus charge, Cl is getting minus 1 charge. Now, what is the name of this one, in the sense, this Sn name is called tin. Sn charge is 2, therefore we will write Roman letter 2. And Cl minus name is called chloride. Here Sn name is tin, this charge is 4, therefore we will write like this, Cl minus name is called chloride, tin 4 chloride. This tin 2 is called, this tin, Latin name is stannum, Latin name is stannum, therefore it is given from stannum, this word is given. Here also from stannum this word is taken. Here what is there, means here us is there, here ik is there. Us means lower charge, ik means higher charge. Therefore it is called stannous chloride, it is called stannic chloride. Okay. Stannous chloride structure we'll see. Now we will take a tin stannous chloride SnCl2, Sn we have written, Cl we have written. This tin comes under which group? This tin comes under which group in the sense group 4a, that is carbon, silicon, germanium, tin, lead. Tin lead. Group 4a in the sense this outermost shell contains 4 electrons. This outermost shell contains 4 electrons. That 4 electrons we will write in the form of 4 dots. 4 electrons we have written in the form of 4 dots. Cl comes under 7th A group. Cl comes under 7th A group. 7th A group means fluorine, chlorine, bromine, iodine, astatine. This Cl comes under 7th A group. This valence shell contains how many electrons in the sense 7 electrons. That 7 electrons will give in the form of 7 into mux. 7 electrons we have given in the form of 7 into mux we have given. Next we will go for bonding. Here one bond will give, here one bond will give. Why Cl is making one bond in the sense Cl valence shell contains 7 electrons. It is in need of 1 electron to get octet. 1 electron is need means it will go for one bonding. It will contribute 1 electron for making one bond. Cl is contributing 1 electron, tin also contributing 1 electron, and one bond is formed between Cl and tin. Okay. Now in this SnCl2 we have given. Now in this Sn, this electron, these two electrons are called lone electrons because they are not involving in chemical bonding. Therefore, lone electrons. Two lone electrons. Therefore, we can say this is lone pair. We can say. Now we can say call this is as these two electrons involved in bonding. Therefore, we can say bonding electrons, and two electrons. Therefore, bond pair. We can say. This is single bond. Single bond is all. This single bond is also called what means sigma bond. We can say sigma bond. Therefore, it is sigma bond pair. We can call this is as sigma bond pair. We can call this as lone pair. We can call. Now this tin is having how many lone pair means one lone pair. How many sigma bond pairs means two sigma bond pairs. Two sigma bond pairs. Totally how many electron pairs means three electron pairs. One lone pair and two sigma bond pairs. Totally three electron pairs is there in a tin of SnCl2. Okay, tin of SnCl2 contains three electron pairs. We can say. Okay, so what is the shape of this one in the sense? This shape we can say angular shape. We can say shape of this one is a angular. SnCl2 shape is what in the sense angular. We can say. Then next molecule will take. What is that in the sense? Ammonia will take. In the ammonia, nitrogen is in nitrogen. We will take nitrogen is the central atom, and hydrogen atoms we will take. Nitrogen comes under group 5a. Group 5a contains what are the elements means nitrogen, phosphorus, arsenic, antimony, bismuth. Now we will take what in the sense nitrogen will take. Nitrogen valence shell contains 5 electrons because it is coming under 5th A group. Nitrogen valence shell contains 5 electrons because it is coming under 5th A group. Okay. Now hydrogen will take. Hydrogen valence shell contains 1 electron. Hydrogen outermost shell contains 1 electrons. Okay. Now hydrogen is in need of 1 electron to get a doublet configuration like helium. Therefore, it is contributing 1 electron while nitrogen is contributing 1 electron. Between them, single bond is formed. Here also single bond. Here also single bond. Okay. Why hydrogen is making one bond? Because hydrogen is having 1 electron. It is in need of how many electrons? One more electron. Why? To get doublet configuration. To get a doublet configuration, we can say. Therefore, hydrogen is contributing 1 electron while nitrogen is contributing 1 electron. Between hydrogen and nitrogen, single bond is possible. Okay. Therefore, hydrogen forms one bond with the nitrogen. So ammonia is like this. Now, how the ammonia is there? How the ammonia molecule will be there means if we join three hydrogens, we will get a equilateral triangle. In the equilateral triangle, center point will be there. No, over that N will be there. Like this will be there. This ammonia. How ammonia will be there means three hydrogens. If we join equilateral triangle will be there. In that center point above equilateral triangle center point above what will be there means nitrogen will be there. Like this structure will be there. This structure is called what in the sense a trigonal pyramid. We can call this is as a trigonal pyramid, we can say. Now, this nitrogen is having one lone pair here. One lone pair here. This is a sigma bond pair. How many sigma bond pair nitrogen is having in the sense 3 sigma bond pairs. So nitrogen in ammonia, NH3 is called ammonia. NH3 is called ammonia. We can call NH3 name. We can say as ammonia. We can say nitrogen in ammonia is having the 3 sigma bond pairs, and one lone pair, Okay, this is about ammonia. We can say. Okay, next compound we will take water. Water formula is H2O. Water formula is H2O. Here oxygen will write and 2 hydrogen atoms will write. Oxygen comes under 6th A group. Oxygen comes under which group in the sense 6th A group? Oxygen, sulfur, selenium, tellurium, polonium. 6th A group elements like this. Oxygen, sulfur, selenium, tellurium, polonium. This oxygen valence shell contains 6 electrons because this is coming under 6th A group. So oxygen valence shell contains 6 electrons because it is coming under 6th A group. Okay. Hydrogen, you know that hydrogen is having 1 electron. Okay. Hydrogen is in need of 1 electron. Why? Because it wants to get duplet configuration so that it will contribute 1 electron. Oxygen valence shell is having 6 electrons. Therefore, oxygen is in need of 2 electrons in order to get octet configuration. Therefore, oxygen can contribute 2 electrons, 1 electron this side, 1 electron this side. Now, water molecule is formed. Now, this oxygen is having oxygen in water. Oxygen in water is having 2 lone pairs and 2 sigma bond pairs. Totally 4 electron pairs. 2 plus 2, 4. 1 electron pair means 2 electrons. So 4 electron pairs means 8 electrons. 8 electrons means obeying octet. Therefore, this oxygen in water obeys octet rule. We can say. Okay. So like this, we said what in the sense water molecule we said. Next we will take SF4 we will take. S is called sulfur. 4 is called tetra. F is called fluoride. Sulfur tetrafluoride. Here sulfur atom we will take. Sulfur comes under which group in the sense 6th A group. See that 6th A group sulfur comes. Therefore, this valence shell contains 6 electrons we can say. This valence shell contains how many electrons in the sense 6 electrons. Okay. So 6 electrons present in its valence shell. So this valence shell we said 6 electrons. Okay. Therefore 6 dots we have given. Then fluorine we will write. 4 fluorine atoms we have written. Fluorine comes under 7th A group. Therefore this valence shell contains 7 electrons. Fluorine valence shell contains 7 electrons. Like this we can write. Fluorine valence shell contains 7 electrons. Fluorine valence shell contains 7 electrons. Therefore it is in need of 1 electron to get octet. So it will contribute 1 electron. Therefore it can make single bond. Okay, fluorine can make single bond. Okay. Now in the sulfur, these 2 electrons are not involving in bonding. Therefore it is called a lone pair. So sulfur in SF4 has 1 lone pair in the valence shell. Then how many sigma bond pairs in the sense 4 sigma bond pairs. So totally how many electron pairs in the sense 5 electron pairs. 5 electron pairs means 10 electrons. 10 electrons in the sense more than octet. 10 electrons in the sense we can say more than octet. We can say more than octet in the sense electron rich molecule. Why? Because greater than octet. It is not obeying octet rule. What octet says more than that it is having. Therefore electron rich molecule we can say. This SF4. So next we will take a BRFI we will take. BRFI. In the BRFI, central atom is bromine and 5 fluorine atoms are there. 1, 2, 3, 4, 5. Okay. Bromine comes under group number 7A. It is coming under group number 7A. Therefore, for this 7 electrons we will write. We have written 7 electrons, therefore 7 dots. Fluorine comes under group number 7A. Therefore, this valence shell contains 7 electrons. This valence shell contains 7 electrons. Okay. Fluorine valence shell contains 7 electrons, so it is in need of 1 electron to get octet. Therefore, it makes one bond with bromine. So each fluorine makes one bond with fluorine. Each fluorine makes one bond with bromine. Now, bromine in BRFI. Bromine in BRFI has 1 lone pair and 5 sigma bond pairs. 5 sigma bond pairs. That means totally 6 electron pairs. 6 electron pairs means 12 electrons. 12 electrons means we can call this as electron rich molecule, we can call. Okay. We can call this as electron rich molecule, we can say. Next, we will take ClF3. This ClF3, Cl is called, Cl name is chlorine. 3 called tri, F is called fluoride. Chlorine trifluoride, we can say. In the before we discussed BRFI. This BRFI shape is what in the sense square pyramid. Square pyramid, we can say. This SF4 name is what in the sense seesaw shape. In the playgrounds and all, seesaw will be there for playing. Like this shape it is. Seesaw shape it is. Okay. So these two acting like a legs. These two for sitting. Here one person can sit. Here one person can sit. Like this. Okay. So this is a seesaw shape. It is square pyramid. Why it is square pyramid means if you join these 4 fluorine atoms, you will get a square. Therefore, square pyramid. We said ClF3. We'll take Cl and 3 fluorine atoms will write. Chlorine comes under 7th A group. Chlorine comes under 7th A group. Therefore, this valence shell contains 7 electrons. This valence shell contains 7 electrons, we can write. Fluorine makes single bond, we said. Fluorine makes single bond. So, this is ClF3. In this ClF3, chlorine in ClF3 has how many lone pairs means 2 lone pairs and 3 sigma bond pairs. 3 sigma bond pairs. So totally 5 electron pairs. Therefore, 5 electron pairs means 10 electrons. 10 electrons means greater than octet. Therefore, electron rich molecule we can say. This shape is just like T. Therefore, we can call this as a T shape we can call. We can say this shape is a T shape we can say. Next molecule we will take xenon difluoride. Xenon difluoride in the sense central atom is what in the sense xenon and 2 fluorine atoms are there that we have written. Fluorine comes under 7th A group. Therefore, this valence shell contains 7 electrons. So here also this valence shell contains 7 electrons. Xenon comes under which group in the sense 0 group? 0 group in the sense helium, neon, argon, krypton, xenon, radon. So this xenon valence shell, that means from neon to radon, valence shell contains how many electrons means 8 electrons, but helium contains 2 electrons. So xenon valence shell, xenon outermost shell contains how many electrons means 8 electrons. That 8 electrons we are writing like this. 8 electrons we have written like this. Now, xenon valence shell contains 8 electrons means it is octet. Xenon outermost shell contains 8 electrons means it is octet. Octet means stable. Therefore, xenon do not go for chemical reaction under normal condition. Xenon is not undergoing chemical reaction under normal condition in the same way neon, argon, krypton and radon. Helium also not undergoing chemical reaction. Helium outermost shell contains 2 electrons. Helium also not undergoing chemical reaction. So, during the time of Mendeleev, at that time, Moseley's periodic table, that means modern periodic table was not introduced. At that time, the modern periodic table was not introduced during that time. Mendeleev periodic table introduced. While these gases did not form any compounds, did not involve in chemical reaction. So, at that time, they thought that these are not involving in chemical reaction because these elements are stable. And also, these are existing as monoatomic molecules. They are having higher stability. Therefore, they are not undergoing chemical reaction. That means their electronic configuration is stable configuration. So, by seeing this, octet rule is introduced. Octet rule in the sense these atoms are having 8 electrons in its valence shell or outermost shell. They are not involving in chemical reaction because 8 electrons means outer shell contains 8 electrons, therefore it is stable. So that only octet rule is introduced by seeing these elements. So octet rule in the sense if outermost shell is having 8 electrons, then that is stable as like these noble gases, as like these inert gases. And also they said another thing, helium is having doublet configuration, 2 electrons, doublet configuration, therefore stable. So at that time, they did not know that these elements forming compounds. At that time, no compound of these elements were discovered. Other elements compounds are discovered. And other elements compounds also they analyzed. How it was there in the sense, most of the compounds were having octet configuration and doublet configuration. Therefore, only octet rule said that octet rule introduced if outermost shell or valence shell gets 8 electrons, then that is stable. If 8 electrons are not there, then they will involve in chemical reaction. Like that they said. Then that rule was followed in many years. Then some of the compounds obeyed octet rule. Some of the compounds have not obeyed octet rule. I have not obeyed octet rule in the sense some are electron deficient, some are electron rich. For that case, how they explained? How they explained? Okay, how did they explain? For example, ClF3 will say. In the ClF3, Cl is having 10 electrons in the valence shell. In the ClF3, Cl is having 10 electrons in the valence shell. 10 electrons in the sense it is more than octet. So what scientists they did in the sense they started to explain ClF3 in the another way in order to have octet configuration. This molecule is existing. This molecule is existing means this molecule is stable. Stable in the sense the central atom should have octet configuration. Therefore, in order to explain octet configuration, what they did, that we will see. Now Cl will take and 3 fluorine atoms will take. Chlorine atom in the valence shell is having 7 electrons because it is coming under 7th group. So 7 electrons we have written. Fluorine is having 7 electrons in its valence shell. Okay, because 7th group. Fluorine is having 7 electrons in its valence shell. Fluorine is having 7 electrons in its valence shell. 7 electrons we have written. They said the ClF3. In that ClF3, Cl should obey octet. Cl should show octet configuration. F also should show octet configuration. For that case, what they did in the sense, here they have given normal bond. Normal bond means fluorine has contributed 1 electron, Cl has contributed 1 electron, sigma single bond is formed. Now fluorine is having octet configuration now. Why? This fluorine is having 3 lone pairs now and 1 bond, 1 sigma bond, okay, 1 sigma bond pair. Therefore, how many in the sense? 4 electron pairs. Therefore, 8 electrons. 8 electrons means octet configuration. Okay. So now what they did in the sense, here they did like this. Half bond they have did. In this bond, chlorine contributed electron only is there. Fluorine has not contributed. Fluorine is having 7 lone electrons. Due to this electron, it has got 8 electrons. Therefore, Cl, this F octet configuration is obeyed. In the same way, here also half bond. Fluorine has not contributed any electron. Cl only has contributed 1 electron. Therefore, in this bond, only 1 electron is involved. Okay, Cl is contributing electron to fluorine. Fluorine is already having 7 lone electrons. Fluorine is having 7 lone electrons. 1 electron contributed by Cl. 1 electron contributed by Cl. Contribution in the sense giving for share. Giving for share in the sense Cl is giving 1 electron. That electron is shared by both Cl and F. So totally if you see 8 electrons, therefore it has got octet. Now Cl we will see how Cl is there. 2 lone pairs plus 1 sigma bond pair. It is 1 sigma bond pair. It is half sigma bond pair, half sigma bond pair, half sigma bond pair. How many means? half sigma 1 plus 2. Now if you see 8 electrons, you will get octet rule, octet configuration. So like this, they gave an explanation. But it is not followed later. Why it is not followed later? In the sense, these two bonds behave in one way, this bond will behave in another way, isn't it? What experimental analysis says regarding this explanation? Experimental analysis says ClF3 is having, the experimental analysis we'll discuss later. So in this way, the ClF3 octet configuration is explained. So now we will go for this xenon case. So before discovering this noble gas, these compounds, before discovering these elements compounds, they thought that octet configuration is stable configuration, doublet configuration is stable configuration. These elements do not go for chemical reaction because they are having stable configuration. They are having stable configuration. Then they said these elements do not go for chemical reaction, therefore they are inert, chemically inert. These are existing as gases, therefore they are inert gases, we can say. All these elements exist in the form of gaseous state. In the modern periodic table, in the long periodic table, only one group which is having only gas, in the sense this group only. In the modern periodic table, 18 groups are there as per IUPAC. Out of 18 group, only one group is having all the elements in gaseous state, that is only this group. This group is called inert gases, we can say. And other elements are involving in chemical reaction. Why? Because in order to get like this configuration, that's why other elements are undergoing chemical configuration, they say. Next, Bartlett is the scientist name. Bartlett is the scientist name. What he did in the sense, he took O2 and he took PTF6. Using these two, he prepared one compound. What is that compound? In the sense, O2 plus PTF6 minus. He took one compound, one molecule O2, another compound PTF6. He treated both. He got like this compound. That means O2 has converted into O2 plus. O2 has converted into O2 plus by losing one electron. By losing one electron, we can say. By losing one electron. PTF6 becomes PTF6 minus by gaining one electron. By gaining one electron, we can say. Getting plus charge means losing electron, getting minus charge means gaining one electron. So, Bartlett prepared like this compound. Then, after preparing this compound, he got one idea. What is that idea? In the sense, this O2 loses one electron and become O2 plus. That means we have to remove one electron from O2. We have to remove one electron from O2, then O2 becomes O2 plus. To remove one electron, we must supply energy. We must supply energy. Then only we can knock one electron from O2. To knock out an electron from O2, we must supply energy. Isn't it? Sir. Then suddenly he got one idea. What idea? In the sense, he got an idea of xenon. This is xenon. From xenon, he removed one electron and he got Xe plus. From xenon, he removed one electron, he got Xe plus. To remove one electron, we must supply energy. We have to supply energy to remove one electron from xenon. Sir, Here energy required to remove one electron from xenon and energy required to remove one electron from O2, they are equal. Experimentally they are equal. That means when O2 forms O2 plus, why not xenon into Xe plus? When O2 reacts with the PtF6, why not xenon? Why not xenon? That question arose in his mind. Immediately he started to make these two react, xenon and PtF6. Okay. So he made a xenon and PtF6 to react. He got a compound, orange colored compound like this. He got a orange colored compound like this. So after Bartlett revealed this idea, many scientists started to discuss about inert gases chemical reaction. This inert gases chemical reaction. Then they tried, they achieved xenon formed many compounds. Xenon formed many compounds. Xenon compounds, many compounds they discovered, they prepared. Xenon compounds, many compounds they prepared in the laboratory. Then they started to say these elements are called noble gases, no longer inert gases. Noble gases, they said. Why they said noble gases? In the sense they also undergo chemical reaction under drastic condition. What is a drastic condition? Drastic condition means not normal. So under drastic condition, these elements also forming compounds. Xenon compounds, they discovered many. So among them, one compound is XeF2. That XeF2 will take. So now we are taking what in the sense XeF2 we are taking. In the XeF2 central atom xenon and 2 fluorine atoms we will take. So this xenon outermost shell contains 8 electrons. Therefore, we will keep 8 dots. We will keep. We kept 8 dots. 8 dots we kept. Okay. Fluorine valence shell. Fluorine can form single bond. Fluorine, okay, can form single bond always. It never forms more than one bond. It never forms more than one bond. No compound of fluorine contains more than one bond. You take whatever the covalent compound of fluorine in which one fluorine atom will make only one single bond. That's all. Fluorine never forms more than one bond. So from the experimental analysis, we came to know that fluorine can form one bond. Okay. Fluorine can form one bond. That's all. Set. Now we will see xenon in XeF2. Xenon in XeF2, if you see, it has 3 lone pairs and 2 sigma bond pairs. Therefore, totally 5 electron pairs. 5 electron pairs in the sense 10 electrons. 10 electrons in the sense electron rich molecule as per octet rule. After the discovery of noble gas compounds, octet rule octet rule lost its value. Therefore, since octet rule has lost its value, such a type of explanation also scientists started not to use. Such a type of explanation also they avoided to use. Therefore, only we gave ClF3 like this shape. Okay, like this shape. Off bond we have not given. Okay, so now, so xenon in XeF2 is behaving like this. Okay, what is the shape of this one in the sense a linear shape? And what is the bond angle? Means 180 degree. Bond angle is 180 degree. Bond between these two bonds, angle between these two bonds is 180 degree. We set. Next compound we will take. Next compound is xenon tetrafluoride. We will take. In this xenon is the central atom, and 4 fluorine atoms we will write, and 4 fluorine atoms we have written. Okay, xenon tetrafluoride we say. Xenon valence shell contains 8 electrons. Therefore, for xenon, 8 dots will give 8 dots we are giving. This making a bond, this making a bond, making bond, making bond. Okay. Xenon in XeF4. Xenon in XeF4 has 2 lone pairs plus a 4 sigma bond pairs. 4 sigma bond pairs. Okay. Xenon in XeF4 is having 2 lone pairs and 4 sigma bond pairs, we can say. So totally how many means 6 electron pairs. Totally 6 electron pairs. Therefore 12 electrons. Therefore 12 electrons we can say. So electron rich molecule. Okay. XeF4 is electron rich molecule. It is what in the sense square planar. It is square planar. Why the shape is square planar in the sense? These 4 fluorine atoms, if you join, you will get a square structure, therefore square. All the 5 atoms in this XeF4, 5 atoms are there. All the 5 atoms present in a one plane, therefore planar. Therefore, the shape of this molecule is square planar, we can say. Okay. Next molecule we will take XeF6 we will take. In the XeF6, xenon is the central atom and the surrounding atoms, 6 fluorine atoms. 6 fluorine atoms are surrounding. So, xenon valence shell contains 8 electrons. Why 8 electrons in the sense? Because it is coming under 0 group. So, this valence shell is having 8 electrons. Each electron making bond with the fluorine. Okay. Now, xenon in XeF6. Xenon in XeF6 is having 1 lone pair and 6 bond pairs. Therefore, totally how many electrons means 14 electrons, 14 electrons in the outermost shell. 14 electrons in the sense we can call this is as a electron rich molecule we can call. We can call this is as a electron rich molecule we can say. So, this about what in the sense XeF6. Next we will see, we'll take carbon dioxide molecule. In the carbon dioxide molecule, 2 oxygen atoms present, 1 carbon atom present. Carbon comes under group number 4A. Therefore, this valence shell contains 4 electrons. Oxygen comes under group number 6A. Therefore, this valence shell contains 6 electrons. Now, carbon in need of 4 electrons to get octet. So, carbon can contribute 4 electrons. Carbon can contribute 4 electrons. Okay. Now, oxygen valence shell contains 6 electrons. Therefore, oxygen is in need of 2 electrons to get octet. So, oxygen can contribute 2 electrons. Oxygen contribute 2 electrons. Carbon contributes 2 electrons to each oxygen. 2 electrons to each oxygen. Okay. Therefore, here carbon contributing 2 electrons to this oxygen, oxygen also contributing 2 electrons. Therefore, double bond is possible. Double bond is possible. Here also double bond is possible. Okay. So in carbon dioxide, how the bonding is there, we got idea. Double bond means what? How to say double bond in the sense? Double bond like this is that one bond we have to call it as sigma bond. Another bond we have to call it as pi bond. Another bond we have to call it as pi bond. For that symbolic representation like this, sigma bond, sigmalic representation like this. So double bond in the sense, out of 2 bonds, one is sigma bond, another one we have to call it as pi bond. For pi symbol we have given. Okay. So in the carbon dioxide, carbon is having 2 sigma bonds, 2 sigma bond pairs, and 2 pi bond pairs. No lone pairs. No lone pairs for carbon. Carbon in carbon dioxide is not having any lone pairs. 2 sigma bond pairs are there, 2 pi bond pairs are there. Therefore, totally 8 electrons.